speakers from Marvell today. Our first speaker is going to be Yaniv Kopelman. Yaniv is Vice President and Switch CTO at Marvell, where he's responsible for defining the company's Ethernet switching roadmap and researching new technologies for the company's networking solutions. And then the second speaker is Hongjik Kim, who's Senior Director of Wireless Modem Engineering in Marvell's Infrastructure Processors business, where he's developing the Octeon Fusion processors for 4G and 5G base stations. And he joined Marvell through the 2018 acquisition of Cavium. Yaniv and Hongjik will be presenting the fusion of network and baseband processors in 5G Fronthaul. And I can see the slides. And Yaniv, if you can turn on your camera and unmute yourself.
Thank you very much, Bob. Hello, everybody. I'm very happy to speak to you today at the Linley Spring Processor Conference. With me presenting is Hongjik Kim, Senior Director in our Infrastructure Processor BU. So Hongjik leads our baseband product architecture team. And as Bob said, my name is Yaniv. I'm the CTO for our Switch business unit. Today, we're going to talk about two topics that are very close to our hearts: baseband processors and Ethernet packet processors. We will try to describe how both worlds meet to support the demand of the 5G fronthaul and the future of 5G infrastructure. So this is the agenda for today. We'll talk about the market, and then we will dive into the 5G fronthaul types and fronthaul evolution, and conclude how the combination of networking and baseband comes together. Let me put here the laser pointer. So the 5G rollout is outpacing 4G and is evolving in a very high speed. It took LTE almost double the time to reach the same infrastructure revenue as 5G today, as you can see from this graph. And by the end of this year, 5G equipment revenue will exceed 4G. The deployment, especially in China, is reaching new heights. Operators collectively activated more than 20K sites per week on the second half of last year in China. In the US, T-Mobile is rolling out almost 1K sites per week as we speak. This is not only happening in North America and APAC, it's also happening in Europe. And even in my small home country, deployment Israel, it started the end of last year. So it really means that it's getting there. So let's see how radio access network may change when moving from the previous 4G networks to 5G networks. On the top, you can see the traditional RAN network. The name of the interface connecting between the RRH, the remote radio head, sometimes also called RRU, remote radio unit, is CPRI, Common Public Radio Interface. This is a TDM-based interface running over point-to-point links. And the first evolution is the introduction of eCPRI, also called enhanced CPRI. Instead of a TDM channelized interface, eCPRI is based on standard Ethernet packets. This allows to introduce fronthaul networks instead of the point-to-point configuration. And this is the first step toward the concept of Cloud RAN. It allows centralized baseband resources to use a larger pool and to serve a large amount of RUs. The second evolution is the possible split of the base station to a DU and a CU. The DU function is a distribution unit, is responsible for the digital signal processing, and it needs to be relatively close to the RRH. The CU, the central unit, is handling most of the 5G higher level protocols and the packets manipulation. Note that even in 5G, there will still be RU that are connected directly to a base station via an interface, which is an eCPRI interface, as opposed to the CPRI interface in the legacy. Fronthaul deployment can be realized using different technologies. In locations where fabric is scarce, many fibers to one is preferable. A technology that allows not having many fibers and logically keep the point-to-point connection between the RRU and the base station is called WDM, or wavelength division multiplexing, that places each fiber connection in a different color or optical wavelength. Another technology is PON, passive optical network. This technology uses a TDM method to transfer the data from each RU to the base station. It is widely deployed in the broadband space, so it is relatively inexpensive and robust and can reuse existing PON deployment where applicable. However, due to the TDM nature of this interface, it adds latency, which may be an issue for a Fronthaul. And finally, active Ethernet. Active Ethernet can utilize to do statistical multiplexing, aggregating to fewer ports on the base station. It can use gray optics transceivers, which are lower cost than the tunable lasers required for the passive optical MUX. And it brings capabilities in terms of looking at the network visibility and can bring better utilization and can drive better utilization of the network. If Ethernet switch is used, it also opens the path to converge between the backhaul and the fronthaul, which I will talk about more in a few slides. I'd like to talk about key features of the fronthaul. First of all, the high bandwidth. Increasing the total traffic toward the DU, requiring the higher network capacity. Also, the separation of the base station to a DU and the CU loads the network with additional traffic that previously was sent inside the base station. The functional split between the RU and the DU requires low latency and accurate clock synchronized between the antenna and the DU. The traffic sent over a fiber from the RU to the DU is running in free space. That needs to be secured and calls for security encryption, which is implemented by hop-by-hop MACsec security. RAN disaggregation is the ability to split the functionality between the DU and the CU, and it enables compute and DSP resources sharing between the RUs. Above all, the introduction of open protocols between antenna and the DU is a major change in 5G RAN. It will enable operators to use equipment from different vendors with full interoperability. O-RAN is the standard promoted by many carriers, and Hongjik will explain more about this standard. So the way RAN network will evolve is not known, but we believe the future lies in a concept called AnyHaul or xHaul. Instead of having multiple networks, each with dedicated switches that have different capabilities, the network will evolve to one network that provides any-to-any connectivity and provide the functionality needed by all. When I say all, it can include users that are not even related to the 5G RAN, like home users and business users. All of them will use the same network that drives also the traffic from the RRU. Imagine that you have a cell tower that resides on the rooftop of one of these enterprises or one of these buildings. Why would you create two networks? One for backhauling the enterprise traffic and one for backhauling for sending a RAN from an antenna that sits on the same building. Why not use one network to pass both information? The AnyHaul network will just forward the packet according to the destination address of the packet. And the AnyHaul network also calls for new type of equipment. The networking equipment used in the AnyHaul needs to handle two different types of traffic. On the one hand, low latency time-sensitive radio data switched using layer 2 protocols to or from the RU to the DU. On the other hand, broadband traffic from the business and home users are routed through layer 3, mandating SLA enforcement, operation and management protocols, and network slicing technologies. This calls for a new switch, which we call an xHaul switch, that have unique requirements. The switch needs to support any-to-any connectivity via the layer 2 switching and also layer 3 routing. The RAN traffic requires low latency and low jitter, supporting features like cut-through and sub-microsecond latency. The combination of RAN and broadband also benefit from a feature called preemption, where express traffic that can preempt other traffic that is less latency sensitive. Accurate Class C and Class D PTP protocols and synchronous Ethernet protocols will enable transferring an accurate clock between the DU and the RU. The xHaul switch will support network slicing to enable separating traffic from different operators that run on the same network. Also, our hierarchical QoS is required to enforce service level agreement on the broadband traffic that is as done in the backhaul network. And of course, hop-by-hop encryption using MACsec will be used to enhance the security of the Fronthaul network. Any xHaul network is a challenge, but also an opportunity to converge the network and reuse network processor resources and fibers that are already deployed. And now I pass it to Hongjik to discuss more aspects of the radio network and how it all comes together.
Thanks, Yaniv. Before talking more about O-RAN and how DU is evolving, I would like to briefly go over organizations standardizing LAN specification, architecture, and interfaces. 3GPP defines baseline LAN protocol specification, including 5G new radio or standard. C3 is traditionally used as a radio interface with limited interoperability. In order to promote openness of the network, various organizations such as O-RAN Alliance and the Open LAN under Telecom Infra project are defining open interface standard. O-RAN Alliance is a specification group defining next generation LAN infrastructures empowered by principles of intelligence and openness. Open LAN is accelerating multi-vendor interoperable product and solutions that are easily to integrate in the operator's network and be verified for different deployment scenarios. Small Cell Forum is accelerating deployments by removing commercial and the technical barriers and defining interoperable interface between layers. All activities are backed up by Open LAN Policy Coalition, who promotes adoption of open and interoperable LAN solutions. Associated software activities by SD-LAN and then a Small Cell Forum are all contributing to O-RAN software community under the Linux Foundation project. As LAN is disaggregated and standardized, new interfaces are also being defined and standardized. Traditionally, LAN architecture were based on monolithic building blocks, where very few interfaces are required between logical nodes. On the other hand, LAN is being disaggregated into RRU, DU, and CU, which allows scalable and cost-effective network deployment. However, it can be possible only if they are interoperable across different vendors. Depending on the use case and the deployment scenario, functional split have various options, such as option 8, where most of the layer 1 and layer 2 functions are running at the DU in the far edge of the network. Option 2, where all of the layer 1, layer 2 are processed at radio unit on the site. Among these options, split 7-2, where low-fi is running at RRU, while the hi-fi and the L2 running at the DU, it becomes more popular. The O-RAN defines interfaces over Fronthaul network between RU and the DU for interoperability across different vendors for the 7-2 split. In order to achieve interoperability, standard protocol O-RAN not only defines user plane data formats, but also defines control plane, management plane, and the synchronization plane protocols. These would ensure O-RAN DU from one vendor can communicate with and control O-RAN RU from another vendor. Another point of interest is how emerging massive MIMO technology impact LAN architecture. With massive MIMO technology, the functional split 7-2 becomes more important in viable options, since it can reduce traffic over Fronthaul dramatically. With a typical 64, 128, 256 antenna elements. Antenna samples are reaching 1 terabps at the very front end of the radio unit, which can only be reduced if low-fi, including IFFT, and the digital beamforming are performed at the I/O side. Additionally, EC pre-compression defined by the ORAN standard can reduce the overall throughput down further to 30 gigabps in Fronthaul for each massive Mimo cells. So next, I would like to talk about DU architecture trends and how the switch becomes an important element of DU, even for the Fronthaul. DU architecture has been evolved with a few key trends. First, higher level of densification is required to support a larger number of RUs by co-located DUs. Second, Ethernet-based Fronthaul supporting open protocol like ORAN becomes more important and for interoperability. Third, flexible resource pooling across multiple baseband compute units are required for efficient hardware and software resource utilization. So these trends require the introduction of the switch, not only for the mid-haul and the backhaul interfaces, but also for Fronthaul interfaces. The Fronthaul interface, switch needs to provide a few following key features. High number of fan-out flexibly connecting multiple baseband compute units to multiple Fronthaul ports spread across the multiple boards. High switching bandwidth to handle Fronthaul traffics with much higher throughput requirement. ORAN packet classification and the steering so that, for example, management and or synchronization plan packets are classified and steered to controlling CPU, whereas the user and control plane packets to the baseband compute unit. It can optionally perform low-fi signal processing to support legacy RU, where the traditional C3-based RU interface is converted to Ethernet-based interface that can be processed by common baseband compute units. As we have seen in the previous slide, next generation DU is convergence of the switch and broadband baseband compute units. If you look into key element in more details, here are the required components. First of all, on the switch side, we need high bandwidth and the low latency switch fabric, which comes with highly accurate synchronization and the telemetry. High-speed interface for both Fronthaul and mid-haul and backhaul are essential. Layer 2 switch and layer 3 router is mandatory. IPv6 and MPLS segment routing can be used for network slicing. Additionally, classification and steering of the various ORAN packets is essential. Programmability in switch is also required to enable future adjustment to ORAN protocol evolution. We also need hierarchical scheduler and shaper for QoS control. Whereas on baseband computer side, we need high and low-fi digital signal processing as in the traditional DU. On top of that, we need a number of features. Not only ORAN acceleration, including compression and decompression is required, but also full ORAN protocol termination, it becomes essential. Software programmable ARM and DSP compute engines are required for flexibility and the future upgradability. Machine learning compute engines enables just-in-time inference of the real-time data for Fronthaul traffic adaptation can be considered as well. Ethernet-based Fronthaul interfaces become a must. Hardware event scheduler should be considered to create dynamic task scheduling across multiple compute units without real-time software overhead is required. Today, we went over the evolution of the 5G LAN focusing on Fronthaul interface. 5G LAN devices new Fronthaul drives new Fronthaul interfaces, which is open and interoperable. Convergence of the broadband and the LAN network, like Fronthaul, is required for cost-effective deployment. It also drives fusion of the networking and the baseband processors. As a proven vendor, a proven SoC vendor in both networking and the baseband processors, Marvell has a very strong IP portfolio required for next generation RAN architecture, and has been leading ORAN and the LAN evolution. Thanks for listening to our presentation today.
So I'll start off with some questions here, and we'll see if we can get some audience questions as well. Yaniv, can you expand on how you can guarantee latency and timing in the converged xHaul network? That looks like a significant challenge when you start talking about the network convergence to hit the latency and timing requirements.
Right. So as I said, there are actually two conflicting requirements in the for traffic in the xHaul market. So one thing you need to be able to separate to identify the RAN traffic versus the backhaul traffic. And then you need to enable different handling of that traffic. So either by doing a scheduling or giving them higher priorities. Another method is to enable a preemption, like I said. So the RAN traffic can actually preempt backhaul traffic that is that can absorb the higher latency. And also it's a bit of a network engineering. You need to make sure that the hops from your antenna to your DU or base station will be actually not exceeding the maximum latency and jitter that you can absorb in this traffic. So it's really both of network engineering and also having the right capabilities in the switch to really enable low latency, low jitter traffic.
So given the limitations in terms of hops, does that mean that this would only this architecture only works in certain geographies? Because I mean, we know that RANs vary a great deal from one geography to another.
Correct. The RAN, given the number of hops, you have a limitation of the distance between the RH and the DU. So we're talking about ranges from 2 to 20 kilometers. And the number of hops is really depending on the equipment that you have and the accuracy of the network that you can get. But really, the RAN is really close to up to 20 kilometers.
Okay, thank you. Hongjik, so you showed this block diagram of a next generation DU SoC. Actually, if you can turn off your screen sharing, then we'll be able to see you full screen. And Yaniv, you can turn your camera on as well. So this next generation DU SoC, is this a concept? Is this a future product? Is this something you're building as a semi-custom product? Can you kind of explain the context here?
As of today, we don't have any single SoC integrated all of these, but we do have a separate product is covering each individual portion of that. And then depending on the market demand, and then we are thinking of creating the SoC based on the market demand. And we do have all the IP portfolios that we can put together to create this SoC.
Okay, so this is more of a.
I would also like to add, Bob. I would also like to add about this. So we're working with different customers to really provide the best solution. Right now, today we can merge both the IP that we have and really support this type of network. In the future, we may optimize that even more, like Hongjik said.
Okay, yeah, I'm aware that Marvell is addressing customers with semi-custom solutions. So presumably, if you have all of the IP and a customer wanted to build such a product, you could actually build a semi-custom product along the lines of that block diagram. On the kind of RAN deployments, I'm curious whether you're seeing a dominant architecture where, for example, the CU and the DU are combined, in one physical unit, or, versus the fully distributed sort of, there's this logical disaggregated network, but in reality, it seems like many networks will kind of combine multiple functions. So are you seeing more of the kind of CU and DU combination, or what are you actually seeing in some of the early deployments?
It's really depending on the geographical regions, because it's depending on their availability of the networks and the infrastructures. So we see the both trends, but definitely the current trend is more like a CU and DU in the co-located in the same spaces. But we also see many places where the CU and the DU is really disaggregated in terms of the location as well.
Okay. And then in terms of the splits, I think, Hongjik, you mentioned the 7.2 split. It seems like there's a pretty big difference between the bandwidth requirements of, let's say, a kind of mid-band base station versus millimeter wave, where you've got maybe 800 megahertz of RF bandwidth. And you almost have to do more processing in the radio unit, or the fronthaul demands become kind of untenable. So are you seeing a kind of a split, and with no pun intended, a split between the different split implementations between maybe what you see in mid-band versus what you see in millimeter wave?
Yes, that is correct. Very correct. That's a very good question, actually. In the millimeter wave, more trend is actually because it needs to handle more wider bandwidth. So millimeter wave cases, many of the operators as well as the providers actually putting all the digital unit functions in the radio head. So which is more like a close to an option 2.
I'm sorry, can you repeat that? They're implementing the DU function?
This is a very good question. In the millimeter wave cases, because it needs to handle much wider bandwidth and higher throughput, the trend is putting more digital unit functionalities in the radio unit,
right,
which is more close to the option 2.
Right. Okay. So it's more like the RU and DU being combined in the millimeter wave implementation.
That is correct.
Okay. Thank you. I think along a similar line, the small cells have been kind of out there as a way to do densification for a long time, and it seems like small cell deployments, at least in some of the private networks, and particularly for indoor, it looks like maybe small cells will finally start to take off for indoor applications. So do you see, how do you see the indoor cells in particular and small cells kind of fitting into this ORAN picture?
Okay, small cell definitely picking up, because to feed out the gaps in the networks, and then we see the trend that after the first deployment of the major networks, the vendors is actually seeking for small cell applications, and as well as the SoCs and the equipment. And the ORAN perspective, definitely in the Fronthaul, we will not use this any ORAN protocols for the Fronthaul, because it's going to be co-located, or even in the same box, or even in the same SoC. So in that sense, is ORAN, it could be small cell is going to be different.
Okay, thank you. We are actually out of time, so thank you, Yaniv. Thank you, Hongjik. Very interesting topic, and appreciate the presentation.